Hello everyone, and then welcome to another video. So in this video we'll be treating in three-phase circuits, okay, and then after that you just take a look at what three-phase 4Y systems, okay, right? So in case you are new to this channel, don't forget to subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Like the video, share, and let me know your questions in the comment section, okay? Right, so let's dive right into this tutorial video. Okay, so we'll be looking at power in what three-phase circuits. Okay, so this is like an extension of what power circuits. Okay, right, so that's what we treated in what impedance. Okay, when we were treating impedance, we talked about apparent power, active power, reactive power. Okay, but this in what three-phase, that's why we have what the root of 3, root of 3, root of 3 running throughout. Okay, it's the same concept. Now these are the things you need to know. Okay, so you need to know these three formulas. Okay, these three formulas, and then you need to know this formula too. Okay, right, so let me just try explain them and then we proceed from there. Okay, right, so this is apparent power. This is the formula for apparent power. Okay, you already know what VL and IL is, okay, from three-phase circuits. We have active power, okay, and then we have what reactive power. Okay, now whenever the parallel loads are not of the same kind, okay, so that's when in a question you are given what both delta and star mixed together. Okay, you have to change either all the stars, okay, or change all the deltas. Okay, this is what I mean. So whenever you are given a question, then you have both delta and star mixed together, you have to change all the stars, okay, to either delta or all the delta to stars, so that you end up with the same what parallel loads. Okay, right, so in case you have a question you've been given what maybe the star is this and delta is this, okay, just change the delta to star. Okay, so in simplicity, make sure to always change delta to star, okay, so that it becomes simple. So this is how you change delta to star. So for this you'll be given the impedance for delta, okay, and then you'll be given the impedance for star in the same question. Okay, so all you have to do is just change the delta, okay, there's impedance for the delta to star. So once doing that, you have to just divide the entire impedance for the delta by 3. So after finding that value or that corresponding impedance, that means that you've been able to convert the delta to star, right? Let's proceed. Let's solve a question and then we call it okay, we proceed to three-phase 4Y, okay, systems. Okay, so now we have what a star connected motor is connected to a 400 volt. So from here you could notice that we have only star, so we don't have a mixture. Okay, right, so let's proceed. A star connected motor is connected to a 400 volts, okay, three-phase. Okay, right, so 400 volts, three-phase, okay, star connected, okay, and then 50 Hz frequency line. Okay, and then one thing you need to know is that the only point, okay, the only way you'll be using these formulas is when the question requires what a line calculation. Okay, so I'll elaborate on that. Okay, right, so and then the motor produces an output power of 268 1 kilowatts, okay, at efficiency of 93% and power factor of 0.9 lagging. Okay, calculate the active power absorbed by the motor. So from here you won't be using this formula. Okay, you won't be using the active power formula for this because you don't be asked to use to calculate for line. Okay, you are just calculating the active power. Okay, and then we have what reactive power. The same applies to this reactive power absorbed by the what motor. Okay, apparent power supplied by the transmission line. Okay, now you'll be using this formula. Okay, apparent, okay, because you are asked to what to find out the apparent power supplied by the transmission line. Okay, take note of those stuff. Okay, and then the motor line. Okay, right, so let's try solving that. Okay, let's look at our solution. Okay, so from here we've been given what 400 volts and then 50 Hz. Okay, so voltage and what frequency. So we have V to what? 400 volts, and then we have frequency to what? 50 Hz. Again, we are given the power output, okay? So the motor produces an output power, okay? Right, so we have what? Power output, okay, to be equal to 2681, okay, kilowatts, okay, and we are given what? Power factor of 0.9, which is the same as what? Cos theta, okay, and then we have what? Efficiency, okay, efficiency of 93%, okay, that's equal to what? 0.9, okay. So now let's proceed. So we have what? These parameters, okay, these parameters, okay. Let's proceed. So we have to calculate what? Active power, okay. So we have to calculate active power absorbed by the motor. So since we've been given efficiency and what power input, we can just find what power input, okay. This output, so you can find input. So you have what? Output over input, okay. Power output over our power what? Input. So from here, you could notice that our power input, okay, power input is equal to what? Our power output divided by what? Efficiency, okay. So that's equal to what? We have output to what? 2681, okay, and then efficiency to what? 0.93. So when you compute this on your calculator, you end up at what? 2883 kilowatt, okay. Take note of the unit, okay, very important. So these are power input, okay. So most definitely you can find what? Active power, okay. Right, so let's proceed. So let's move on to B, okay. So we found out power input, which is what? The active power, okay. Let's move on to what? Reactive power. So we have B, okay, the reactive power. Now we know that reactive power, okay, you know that our reactive power is equal to what? Our power input, okay, that's what? The active power, okay, divided by what? The power factor, okay. That's from previous calculations. And then we know that the power input is what? 2883, okay, divided by what? Our power factor, which is what? 0.9, okay, 0.9. So when you compute this, you end up with what? 3203. Pay attention to the units, they are very, very important, okay. So right, so we are moving on to what? The apparent power supplied by the transmission line, okay, transmission line, okay. Now, so from here you can notice that we have what? X, okay, and then we know that X is the same as what? Our apparent power, okay. Right, so it means that we've been able to what? Calculate apparent power just by trying to find what? Our reactive power, okay. So let's proceed to finding out what? Reactive power, okay. So now we know that Q, okay, which is our what? Reactive power from here, okay, from here is also equal to what? The square root, okay, of what? S squared, okay, minus what? The P squared. So from here you just calculate, insert your values and calculate, and then you end up with what? Your your apparent power, okay. Right, so that's the reactive power, okay, that's the reactive power, Q, okay. Right, so let's look at S. S is what? 3203 squared, okay, minus P, okay. You've already calculated P to what? 2883, okay. So let's insert that into the equation, okay? Right, so when you compute this, what will you get? When you punch this on your calculator, you end up with what? 1395, okay, kilo VAR, okay? That's reactive, okay? Right. Now, you can notice that we've been able to calculate what reactive power, okay, to be 1395 kilo VAR, okay? So now let's look at C, okay? So C is what? The apparent power supplied by the transmission line. So now from here you can notice that you've already been able to calculate what apparent power, okay? So our apparent power, okay, is equal to what? 3203 kVA, okay? So in case you want to confirm, since this is what transmission line, okay, so you can use what this formula to confirm, okay? You can just use this formula. This formula to confirm, okay? Root of 3 VLIL, okay, to confirm. Now let's move on to what calculating the motor line current, okay? The motor line current, okay? So now, so we have what the motor line current equation to be equal to what? Okay, so initially we know that what S, okay, S is equal to what? Root of 3, okay, and then VLIL, okay, that's what okay, that's apparent power, okay? That's why initially I stated that you can use the apparent power formula to verify what your apparent power for what the C, okay? And then we have to calculate what the motor line current, okay? The motor line current. So we have what IL, okay? So we have IL to be equal to what apparent power divided by what root of 3 multiplying VL, okay? And then we know apparent power to be what 3203, okay? 3203, because this is what kilo VA, we have what 10 exponent what 3, and then we divide that by what root of what 3, okay? And then we have what our VL. If we already know what VL is, okay, that's 4,000, okay? From here, okay, this is our VL, okay, 4,000. So we could just calculate our motor line current, okay, from here. So when you compute the whole of this, okay, when you compute the whole of this, you will end up with what motor line current of what 462 amps, okay, 462 amps. So from here you can just verify this value, okay? So we have S is equal to what root of what 3 VLIL. Because you've been able to calculate IL, you just verify, okay? So we have root of 3 multiplying what VL, which is what 4,000, okay, and you multiply that by what 462, okay? So most definitely you must get something close to this or equal to this, okay, when you compute this, okay? Right, so this was very, very simple and concise. So let's dive right into what the 3-phase 4-wire system, okay? The 3-phase 4-wire system. Now this is the 4-wire system, okay? So for 3-phase 4-wire system, this is the only equation you need, okay? The current in the neutral. So IN is equal to what the current in the neutral. So all you have to do is just calculate the current in A, current in B, current in C, okay? So this similar to this, okay? IPA, IPB, IPC is similar to IA, IB, IC. They are just notations, okay? So let's take an example and then we call it a day, okay? Right, so we have what a 3-phase 4-wire system having the following data, okay? So we have the supply voltage of what 415 volts, impedance 1 to the 8 plus J 0 ohm, impedance 2 to the 0 minus J 8 ohm, and the impedance 3 to what 0 plus J8 ohm. So that's why we have this. Okay, so all you have to do is just use the impedance to find the respective currents. After that, you sum the currents up and you are done. Okay, right? And then we know that we already know this formula. Okay, we've been using this formula for a very long time. Okay, this formula, so you just make the I the subject and you are good to go. Okay, so we have I is equal to what V on what Z. Okay, but for here we are talking about IP. Okay, IPs, VPs, and then a whole couple of what Z. So Z1, Z2, Z3. Okay, right? So let's proceed. Let's write our parameters and then we continue from there. Okay, right? So this could be supply voltage, so this could be VL. Okay, take note of that, VL. Okay, and then we have what our IPs. Okay, right? So we have what our VL to be equal to what 415 volts. Okay, right? And then we have our Z's. Okay, Z. So let's proceed from there. So we have what Z1, Z2, and Z3. So we'll take a look at how the Z's are being represented. This is what positive 8 plus what J0. So this similar to what this format. Okay, so we have 8 plus 0 J ohm. So in case you are writing in polar form, okay, this is something similar to what, something like this. Okay, this is something similar to this, and then we have what Z2, okay, to what 0 minus J8 ohm. Okay, so this is something like, it's similar to a certain what representation in polar form as what minus what 120 ohm. Okay, so these are just representation. Okay, right? And then we have what Z3 to what 0 plus J8 ohm. Okay, so this is something like what 0 and then angle of what positive 120 degrees. Okay, so let's proceed. So we already know this formula. Okay, right? So we already know this formula, but we have to find what I am VP. Okay, VP. That's why initially I stated that this is what VL, but in calculation you will need what VP on what Z. Okay, which should be equal to what IP. Okay, so let's find VP. Okay, so now VP has to be equal to what VL divided by what root of 3. This means that VL is equal to what root of 3 multiplying what VP. That's the relationship. Okay, so in our previous video I showed, or I just introduced this formula to you in case you remember. Okay, right? So we have VL to what 415. Okay, then we divide that by what root of 3. Okay, so we end up with what our VP to be equal to what 240 volts. Okay, so now let's proceed with the calculations. Okay, these calculations are quite simple. Okay, right? So we just pick up our VP, which is equal to what ZP, and then what IP. So let's just make IP the subject. We have what VP divided by what ZP, but for here we are using what VP divided by what Z1, okay, Z2, and then what Z3. Okay, right? So let's continue from there. So we have what the first one is what IP1, okay, to be equal to what VP, which is what 240 divided by what our first Z1. Okay, so first Z1 is what 8 plus JO. Okay, so when you compute this, you end up with what? When you compute this, you end up with so from here you can also write this in what polar form. Okay, that's why I try to introduce this. Okay, introduce this in this format. Okay, and how they have to be represented in what the polar form. Okay, these are not exact, but these are just a representation of how your voltages must look like. Okay, right? So that's why for Z1 we have what? The voltage with an angle of what? 0 degrees. Okay, yes, from here. So when you compute this, you end up with what? This what? 30 and an angle of what? 0 degrees. Okay, let's move on to IP2. So IP2, we have what? 240 divided by what? 0 minus J8. Okay, so from here we have this. Okay, so it means that this is also equal to what? 240 and an angle of minus 120 degrees. Okay, right. So let's compute this, and then we end up with what? 30 and then what? An angle of what? Minus what? 30 degrees. Okay, let's continue, and then we have what? IP3. Okay, to be equal to what? 240 divided by what? 0 plus J8. Okay, so this is what? Plus J8. So it means that this is what? Positive 120 degrees. Okay, so when you compute this, what will you get? So you end up with what? 30. We could see that is the right opposite to this one. Okay, it's like the reciprocal. Okay, so you have 30 and then you have an angle of what? Positive 30 degrees. Okay, right. So let's find out what we have to find what? Current in the neutral. So we've calculated for the what? The load currents. Okay, that's IP1, IP2, IP3 corresponding to what? Z1, Z2, Z3. So we have to find what? The current in the neutral. What? The current in the neutral. Okay, right. So that's what? IN, which is equal to what? IP1 plus IP2 plus IP3. Okay, so this is equal to what? 30 an angle of 0 degrees plus 30 with an angle of what? Minus 30 degrees plus 30 with an angle of what? Positive 30 degrees. Okay, so when you compute all of this, what will you get? Okay, so when you compute this, you will end up with what? 82 amps. Okay, this will give us what? 82 amps. Okay, right. So this brings us to the end of this tutorial section. Okay, so in case this video was very helpful to you, I would urge you to subscribe so that you don't miss out on any other educational or informative videos which would help augment your studies. Okay, kindly like the video so that it gets pushed to other students who might need this video to boost their academic confidence. Okay, share the video, kindly share, okay, to your colleagues, and then in case you have any other questions, just let me know in the comment section and then I'll reply to them as soon as possible. Okay, have a lovely day. Bye bye.